Back to today's lesson, financial interest. Financial interest. Yesterday we talked about exponential growth and exponential decay. We're going to continue talking about growth, but the growth we talk about is about finances. So what we're going to talk about is all related to money, financial interest. So how does money grow? There are several different ways in which money could grow. This is not part of Edmodo, so you have to write this down. You could either compound. Money can be compounded annually. If money is compounded annually, use the regular growth formula that we used yesterday. So yesterday we used y equals a 1 plus r raised to the x power. Remember this. Uh, if it's compounded annually, please make sure you make a note because we're going to have different rules for different types of compounding. If it's annually, use the regular growth. The only difference is when we're talking about financial interest, instead of A, you may see the word P, the letter P used instead of A. P just means the principal. It's still the same formula, they just use different variables. We'll just use P, sometimes you'll see P, sometimes you'll see A. It's the same thing. P is just your principal. And this is your starting amount. And the X is just going to be a T, but everything else is the same. T is just your time. But the formula is exactly the same as the one we used yesterday. This is exponential growth. Any questions about compounding annually? P is your principal, that's the amount you start with. T is your time. If you create a model, just change the T to an X so you can put it in your calculator and then look at the table. Is everyone clear about this here? Compounded annually. The next type of compounding is continuously. So you could compound continuously. This word is very, very, very important. Make sure you burn this into your subconscious and press it there continuously. Every time you see continuously as part of the instructions or as part of the directions, you're going to use a different formula. This is the PERT formula. So Y equals P times E raised to the RT. P again is what? Your principal. So P is just your starting amount. E is just a button on your calculator. I'll tell you what E is. You don't really need to know what E is, but I'll tell you in a second. R is your rate. The rate has to be used as a decimal, not as a percentage, and T is the time. So when you make the model, you could just substitute X for T, put it in your calculator, and then look at the table and get your answer. So what is E? I'll talk about E real quickly. E is known as Euler's number. It looks like Euler's, but it's pronounced Euler's. It's Euler's number. It's a constant. The value is 2.71828. Dot, 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 dot. It's an irrational number. It's irrational. And it's the second most famous irrational number, the first one being pi. So you all know pi equals 3.14, dot, 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 goes on forever. Instead of just typing this number out, you use the pi button whenever you're solving something. E is very similar to pi. It's another irrational number. It's the second most famous number. It's used to find natural logs. You don't need to know the backstory about this number. Just know that it's a constant. This number never changes. It's constant, just like pi. And it's equivalent to almost approximately 2.71828, dot, dot, dot. That's what E is. And it's a button on your calculator. Can be found right here on top of the division. It can be found on top of the division button. So when you use the continuous growth, it's P, this E button here, raise it to RT. All right, so we mentioned that money can be compounded continuously. annually, and it could be compounded in different other intervals like quarterly, semi-annually, every 2 years, every week. And if you're going to compound it, if you're going to compound something other than annually, we use this formula here. And we're going to talk about this tomorrow, not so much today. This is an R over N raised to the NT. We're going to talk about this one tomorrow, but this formula is very similar to the first one. The only thing is we just have an N, which is the number of times it's compounded per year. We'll talk about that tomorrow. So these are your financial interest formulas. Financial interest. Financial interest. Any questions about the formulas for financial interest? We just know this one from yesterday, and we're going to use this one, compounded continuously today. So first example, you place $900 in an investment account that earns 6% interest compounded continuously. What is the balance after 5 years? Again, the word continuously, I'm going to sound like a broken record because it's very, very important. Do not forget, when you see the word continuously, use this formula, PERT. The word continuously implies that you will use this formula, PERT, P-E-R-T. Principal is the starting amount. The starting amount is 900. E is just a button on your calculator. What's the rate?
6%.
Which is
0.6.
which is
What do you mean? Oh, the interest.
0.6 is not 6%. 0.06. And so here's your option. So pay close attention here. You could A, create a model. Remember models from yesterday. If you create the model, just put an X here, put that in your calculator, look at the table, and you'll get your answer. Or you could put the time, 5, and just solve it algebraically. Do you understand your two options? Yes. All right. So you have choices. You could just put the time here, solve it, or put the X, make the model, and look at the table. Either option you choose, what's the answer? Yusuf, you have a question?
If it didn't say earn, it said like the appreciates, like what we just keep 0.06 because if it is earned, don't we put like 1.06 for the rate?
Not for the PERT formula, only for the exponential growth formula. Does that answer your question? Yeah. So when we use PERT, no one, just the percentage. Good question. Maria G, what you get? That's correct. 1,214.87. Any questions about continuous growth using the PERT formula? Good? All right. Last one, and then you're off to your classwork. Brahm invested $10,000 in an account that earned simple 5% interest annually. How much money will be in the account after 10 years? So based off of this sentence up here, which formula are we going to use? The one from yesterday. It doesn't say anything about continuous growth. If you do not see the word continuous, do not use the PERT formula. So use the regular exponential growth formula from yesterday. Can someone give me the model? What would the model be based off of the data here? Spencer.
10,000 parentheses 1 plus 0.05x.
1 what now?
Plus
Okay.
0.05x.
Raised to the x.
Yeah, raise to that.
Yeah. All right. That's the model. So what's the answer? How much would be in there after 10 years? Not Spencer. Not Spencer. Are there any questions about the model, though? Is everyone clear about the model? All right. So what would the? How much would he have in the account? Not Spencer. How much is Brahm gonna have in the account? Angelina.
Would you look at the 10 on the X?
Yes. Look at 10 and then the corresponding y. So what is y when x is 10? Maria G.
I got 16,288.95.
Yeah. Rounded to the nearest dollar, 16,289. Would anyone like to see that done, or is everyone good on that answer there?
If we're doing with the decimal, I did like this. I didn't use the table.
Okay.
But when I have to include the decimals, I can just write what you have on the board.
Yeah, well, it says to round to the nearest dollar. Yeah, but if it didn't, then since it's money, then you would just round to 2 decimal places. All right, how about B? How much more would the account earn in interest in the first 10 years if the interest compounded continuously? There goes the buzzword again, continuously. So what are they asking us to do here for part B?
Check two.
Uh,
Well,
What are they asking us to do first?
y equals p RT.
Okay,
And then I got y equals 10,000, e 0.05.
hold on, let me just catch up with you. So continuously tells us y equals
P,
raised to the RT, and then you got
y equals 10,000, e 0.05 parentheses 10.
all right. So you just did algebraically, and what did you get?
I got 16,487.21.
All right. Now, did you answer the question? This is correct, but did you answer the question?
No.
What's the question asking you?
How much more?
But this is exactly what you must do first.
And then you subtract that one and that one.
Yeah. So what is the final answer?
I got 198.
Rounded to the nearest dollar is 198.